Good afternoon, teachers. Today we are going to tackle theorems of differentiation of algebraic functions. We will focus our attention to the basic differentiation formulas of algebraic expressions taken from the book of Leithold entitled Tisiwag or the Calculus with Analytic Geometry. The first formula states that the derivative of a constant or the derivative of c is equal to 0. So if you have a function f of x equals 5, then the derivative of that function is 0. The second formula states that the derivative of the power of n with the base x or x to the n is equal to n, your exponent, times x to the n minus 1. So suppose you are given the function x to the fifth. Okay, x to the fifth. So the derivative of that or the derivative of that is 5, which is the exponent, times x to the 5 minus 1, 4. Okay. Then the third differentiation formula states that the derivative of a constant times a function, okay, so you have is equal to c times the derivative of the given function. So that means you are simply to carry out or write down or copy the value of the constant multiplied by the derivative of the given function. Number 4 states that the derivative of c x to the n is equal to c n x to the n minus 1. So that means you have to copy the constant given multiplied by the derivative of x to the n. So suppose our function here is 3x to the fifth, then the derivative of that is 3 times 5x to the fourth, which is now 15x to the fourth. And the last theorem states that the derivative of the sum of the function f of x and the function g of x is equal to the derivative of each. Okay, so the derivative of f of x plus the derivative of g of x. Okay, let's proceed to some examples for you to be able to understand these formulas better. We have example number 1. Find the derivative of f of x equals 3x squared plus 12. I hope this function is familiar to you in our previous videos. Okay, so we are given the function 3x squared plus 12. All we have to do is copy the constant 3 multiplied by the derivative of x squared, which is 2x to the 2 minus 1. And the derivative of the constant 12 is equal to 0. So let's simplify our answer. So we have 3 times 2 is 6. Then 2 minus 1 is equal to 1. You don't have to write 1. So the derivative is 6x. I hope this is familiar already because this was the derivative that we have obtained from the definition of the derivative using the formula f prime of x equals the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. So if you can remember, we obtain the same answer. Okay, so this was the concept, no, the basis of this formula. Okay. Example number 2. Find dy dx if y is equal to 3x to the fifth plus 5x to the fourth minus 2x cubed minus x squared plus 1. So given the function, the derivative with a notation of dy dx, so instead of f prime of x, we can use the notation dy dx. So the constant is copied, 3, then multiplied by the derivative of x to the n or x to the fifth. So you have 5x to the fourth plus copy 5. Then the derivative of x to the fourth is 4x cubed minus copy 2. Then the derivative of x cubed, which is 3x squared, minus the derivative of x squared is 2x, and the derivative of 1, a constant, is 0. So let's simplify. We have 3 times 5 is 15, x to the 4th. 5 times 4 is 20, x cubed. Negative 2 times 3 is negative 6x squared. And negative 2x is negative 2x. Then we don't have to write 0. So this becomes our final answer. Lastly, we have example number 3. Compute for ddx of 1/4 of x to the 4th minus 1/2 x cubed. So, because that's in that notation already, then we can directly write down the equal sign. So again, copy the constant 1/4. Then the derivative of x to the 4th is 4x cubed. Minus copy the constant 1/2. Then the derivative of x cubed is 3x squared. So 1/4 times 4 is 1. We don't have to write 1. And copy x cubed. Then 1/2 times 3 is 3 halves. Then copy x squared. So this becomes our final answer. Thank you very much. This is Dr. Batukan saying, mathematics is easy to learn when one learns with enthusiasm. Bye!